Good afternoon. I'm Mr. Precella, and today we are looking at assignment number 9, rectangular coordinates and graphing. This is the first assignment that that features my lab graphing tools. And it's so funny whenever I'm teaching this stuff. When I was in school, some of these old graphing tools, it'd be science fiction. It would just be science fiction. And there's some really nice graphing tools. Here we go. Here's the thing about using the graphing tools. You have to know what you're trying to graph before you can use the tools, okay? You can't just say, type in the equation and it tells you here's the graph, okay? You have to have some graphing knowledge in order to use the tools. So we're going to be graphing lines, quadratics, cubics, absolute values, and there's something else. Square root expressions. We'll start off with lines. The equation of a line is any equation that can be written in the form ax plus by equals c, where x and y are the variables. You see a lot of letters there. A, B, and C are numbers. X and y are the variables. A, B, and C are numbers, and it should be mentioned one of those first two coefficients could be 0. You could have a 0 times x, so your equation only contains a y, or you could have a b value that's 0, so your equation only contains an x. But you have to have at least one of those variables. And notice, for a line, there are no exponents appearing in the equation. There are no square roots. There are no absolute value expressions. It's just x's and or y's. And to illustrate, let's just look at number 1. There. Give ordered pairs that are solutions and graph the equation. This is number 1. They give us the equation 3y equals 2x minus 6. Oh, there's something. When I look at this equation, let me switch over to my paper. I see all we have are x's and y's. Well, you say they're not on the same side of the equation. That's fine. We can get it in that form, standard form, with the x's and y's on the same side if we wanted to, by moving that 2x over to the left. But we don't need it like that. As soon as we notice we have x's and y's, no square roots, no exponents, no absolute values, so that says that the graph is going to be a line. To draw a line, you need 2 distinct points. To create those ordered pairs, they're going to have us create a table of values. Look at what we have here. It says complete the ordered pairs so they're solutions to the given equation. Look at this table. I call this thing an XY table. Okay. Now look at this table. Look at that row they have there. They have a 0 as the first number, but they don't have a number here there. What is this row telling us to do? We're going to do something with 0. What is that row telling us to do?
Substitute the x in the equation with 0.
Okay, so we're going to substitute that 0 in for x. The y place is empty. That's the value we're trying to find. But this first row of the table says let x equal 0. Then we have 3y equals 2 times 0 minus 6. So we have 3y equals 2 times 0 is just 0 minus 6. I have a negative 6. We're trying to solve for the y value. What is that saying to do? What are we going to have to do here to get y by itself?
Divide.
Okay, so we're dividing by 3, and that's going to give us y equals negative 6 divided by 3 is negative 2. So we found an ordered pair of 0 and negative 2. Maybe I should have reviewed the XY grid. I'll do that in a moment when I'm going to draw, even though we're going to graph the line using one of the tools in my lab, I'm going to draw the line on paper also. So we come over here, and in place of that blue box there for y, we're going to write negative 2. Hey, look at this second row. There's a box and then a 0. What is that saying to do? We have a...
Y for 0.
Okay. Right there. This new row here, this is saying now you're going to let y be 0 and find the number x. So it's saying let y equal 0. So we have 3 times 0 is equal to 2x minus 6. 3 times 0 is 0. And so we have 0 equals 2x minus 6. We're trying to solve for x. What do you think we're going to, what will I do first? To get x by itself, be careful. Add 6, so we'll have 2x on the right side, and over here on the left, what will we have? 0 plus 6, I agree, will give us a positive 6, and then divide by 2 to give us x equals 6 divided by 2 is a positive 3. So at this point, we have 2 ordered pairs. Maybe it'd be helpful to write them as ordered pairs using parentheses. I'm going to write that's 0, negative 2. That's saying the ordered pair 0, comma, negative 2. 3, 0, that's the ordered pair 3, 0. To graph a line, you need 2 ordered pairs. For a line, you need 2 ordered pairs. And that's what we have. We have the ordered pairs 0, negative 2, and 3, 0. Let me see. To graph, we have 2 number lines, a vertical number line and a horizontal number line. The horizontal number line is referred to as the x-axis because of that variable x there. The vertical number line is referred to as the y-axis. Looking at the horizontal number line, it's just like any horizontal number line. To the right is positive. The point of intersection corresponds to 0. To the right, we have a positive 1, 2, 3, 4, and so on. To the left, 1, 2, 3, 4. Left is negative. With the vertical number line, which direction do you think is going to be positive, up or down? Up is positive, that's right. And down is negative. To locate the ordered pair 0, negative 2, you always start at the point of intersection when you're measuring. That's saying go left, right, 0. So we're not going to move left, right. We're going to stay right there where we are. That negative 2, the y coordinate, says you go down 2 units for the ordered pair 0, negative 2. The second ordered pair, 3, 0. The first number gives you your left-right movement, the movement on the x-axis. So you go 3 units to the right, 1, 2, 3. How many units up or down do we go? None. The 2 ordered pairs we found lie on the axes. One of them's on the y-axis, the other is on the x-axis. We connect the 2 dots with a line. In this case, it's a slanted line. Any questions there? Oh, I never typed in that x coordinate, did I? Okay, so right here, what number went in this box, or should go in this box? 3, I agree. And now we're going to graph the thing. Notice they give us this grid right here. What I do, notice the way I have the screen blown up to make the thing bigger on the projection. I don't use this XY grid there. I click here. And notice, yeah, that's a yellow box. Click the graph. Choose a tool in the palette and follow the instructions to create your graph. You have to choose which tool you're going to use. That's why you have to know what you're graphing. You know you're graphing a line, so one of these tools here is a line tool. This first thing, if you hover over each tool, object selection tool, I'll tell you right now, you should not ever need to use that. There's only one figure here that looks like a line. Right here, the second tool, y'all see what it says there if I hover over it? Line tool. It's hard to see this, but the line is gray and there are 2 blue dots. Those blue dots are saying that you need 2 points to use this tool. But we click the line tool. Now it starts talking us through. Plot the first point on your line. What was the first point we got? 0, negative 2. Now some of these grids are going to be very tight. Here they're incrementing by 1, and it's easy enough to count. But sometimes, as we move through this these graphing tool assignments, it's going to be hard to tell counting 1, 2, 3, and so forth. Notice up here in the yellow box, wherever you move your mouse, it's showing you the ordered pair that the cursor's at. We want 0, negative 2. That means left, right, 0, down 2 units. And then click. And notice that blue dot that they made there. It's such a big dot. Now that we've clicked it, it says, click the graph to plot the second point on your line. Notice as I move my mouse around, this tool is drawing every possible line that has the point 0, negative 2. But what was that second point we had? 3, 0?
Yes.
Right there? So we have the 2 ordered pairs, 0, negative 2, and 3, 0. If you're using the pop-out graph the way I am, you'll have to save it, and look what happens once you click save. It transfers the graph back to the line, back to the original graph, and you can say check answer. Any questions there? Some terminology before we do number 2. Any point where a graph passes through the x-axis is referred to as the x-intercept. X-I-N-T-E-R-C-E-P-T. Any point where a graph passes through the y-axis is called a y-intercept. The points that are the easiest to plot are points that lie on those axes. So when you're graphing lines, I encourage you, find the intercepts, the x and y intercept. How did we get this 0.30? Look back at the problem. How did we find this 0.30? Well, let's see. Didn't they give us the y value of 0? And they said find x? So if you're looking for an x-intercept, you have to assume the y value will be 0, and then you can find x. How did we find this second point down here? They gave us the x-intercept of, the x value of 0. We're looking for a y-intercept. The x value has to be 0, and then you can solve for y. If you think about it, if a point is sitting on the x-axis, you go to the x value, but can you move up or down? If you move up or down, are you still sitting on the x-axis? No. So for any point that's on the x-axis, the y value has to be 0. Likewise, if a point is sitting on the y-axis, you can't move left, right, or else you're not on the y-axis. So for any point on the y-axis, you have to assume that x value is equal to 0. Any questions there? Now, y'all are mighty quiet. Maybe we should do a little bit more review with the XY grid on paper before we go on, okay? If you took Math 371 recently, you probably recall this. I've already said that the horizontal number line is the x-axis, and the vertical number line is the y-axis. We said right is positive. We said left is negative. We said up is positive. That's one good thing about the graphing tools. You'll never see a wavy y-axis when you're using those graphing tools. And we said down is negative. Well, we're so quiet about this, we better see. I'm going to label some points on here and see if y'all can tell me the coordinates. That dot right there. Give me the ordered pair representation for that point that I just labeled. Maybe I didn't need this review after all. Okay, so we start here. You go 3 units to the right to get positioned vertically underneath that dot. So the x coordinate is 3. You go up 1 to get a y coordinate of 1. Well, what about something like this one right there?
-2 and 4.
Okay, well, okay, I guess y'all didn't need this review then. You start at the origin, at 0, 0, because you always start your movement right here. That point of intersection is frequently called the origin, O-R-I-G-I-N. That's a terrible looking arrowhead, isn't it? Okay, what about this point right there?
-5, 0.
Okay, wait, I heard 0, -5, and I heard -5, 0. Which one is it? -5, 0, I agree, because you have to go, the horizontal movement is done first. You go 5 units to the left, so the x coordinate is -5. You don't go up or down, so the y coordinate is 0. Remember I said any point on the x-axis, if it's on the x-axis, it has to have a y coordinate of 0. What about this point right there? What would the coordinates of that point be?
-1, -5.
Okay, I agree. And maybe that point right there. What does that look like to you? Oh, and by the way, we're assuming all these numbers that I'm using are integers. You could say, oh, it looks like 4.9999999. No, let's just assume it's integers. 5, -4. Okay, well, it doesn't seem like y'all had trouble labeling those ordered pairs after all. Some more terminology. Notice these two the vertical number line and the horizontal number line divide the flat surface, and I'm going to call this flat surface a plane. They divide it into 4 distinct regions. These regions are called quadrants, so I don't think they use that terminology in the homework, at least not in this assignment, but I might use it. We number quadrants using Roman numerals so as not to confuse it with the numbers on the number lines. So we'd say this is quadrant 1. The upper right-hand corner is quadrant 1. Then we move counterclockwise. Quadrant 2, quadrant 3, and quadrant 4. As I said, we use Roman numerals to number quadrants. We can make some observations about the signs on the ordered pairs. I'll get us started. In order for an ordered pair to be in quadrant 1, you have to go to the right and then up. That means the first coordinate has to be positive. If we're moving up, what has to be true about the second coordinate? It has to be positive as well. Moving in a counterclockwise direction, we'll go left and then up to get into quadrant 2. So what is true about the x-coordinate sign? It's going to have to be negative because we're going left. We're still going up. So the x-coordinate's negative, the y-coordinate's positive. What about the signs of every ordered pair in quadrant 3? Okay, you go left and down, so negative, negative. What about quadrant 4? Okay, well, so y'all were just being quiet. It wasn't that you needed a review on the X, Y grid. Okay. Problem number 2. Complete ordered pairs for the equation and then graph the equation. Hey, they're not giving us an XY table here. Here they're representing the stuff with ordered pairs. That's fine. We know how to handle that. This is number 2. The equation is 3x plus 5y is equal to 15. And they're giving us ordered pairs. There's the first ordered pair they're giving us. And let me make sure I did this copy that. Okay, yeah, that's right. So What is this notation telling us to do? We're going to put in 0 for x, just like we did over here with that first row where they had the 0 in the x column. We'll plug in 0 for x. 3 times 0 plus 5y is equal to 15. 3 times 0 is 0 plus 5y, it's just 5y equals 15. That looks bad. 5y equals 15. So what do we do to solve for y? Divide by 5 to give us y equals 3. I know x and y are the most common variables that are used in algebra classes, but if I ruled the world, y'd be one of those variables I'd outlaw in algebra classes. Why? Those messy tails. You see the way that my y tail got in the way and messed up that line down there? If I ruled the world, oh, I just get tingly all over thinking. Only x. Could you use w? Would w be an acceptable variable by my rule? Does w, when you make a w, do you get a curvy tail down there? No. What about p or q? Could you use those? No, they go below the line, okay? But I suspect I'm almost 60, so I don't think I'm ever going to get to the position of ruling the world. But maybe y'all can carry on, and one of you can carry that torch forward. Look at this next ordered pair. Just like the not the desalination plant, the dehumidifier. Has anyone brought this idea to city council or anything? A friend of ours works for the city, and I told her in all seriousness my plan, and said, you can mention it to the because she has to be at every city hall meeting. You know what she did? She laughed, and I think it's a great idea. I really do. The air out there by the bay, it's so humid. Just think about it. We could make a lot of, well, anyway. I think I'm scaring some of y'all. Y'all tell me, what is the second thing saying to do?
Plug 0 in for...
Oh, I was recording that. I don't normally record that sort of nonsense. Shoot. Well, don't tell Tony. He'll be annoyed. He'll never listen to it. He won't know otherwise, okay? So that says plug in 0 for y. Now, how do we know that it's y that we're letting be 0 instead of x? Because the 0 is in what position? The y coordinate. That's how we know to let y be 0. So we have 3x plus 5 times 0 is equal to 15. 5 times 0 is 0, so we have 3x equals 15. Divide by 3 to get x equals. Divide by 3 to get x equals. Oh, what? Y'all didn't even call out to me. This is terrible. There. Let y be 0. Okay. We plugged in the y, the 0 for y. That gave us just 3x equals 15. Divide by 3 to give us x equals 5. Any questions there? So we have 2 ordered pairs. Okay, 5, 0. Okay, and I'm going to click to enlarge the graph, okay? And once again, it's a line, so we click the line tool. Now we got to click the first point. Realize it doesn't matter which ordered pair you plot first, okay? What did we have as our ordered pairs? We had, let's see, we had 0, 3, and 5, 0. You could start with 5, 0. You'll still get the same graph. With the line tool, it doesn't matter which ordered pair you start with. I think I'll do 5, 0 first. Move 5 to the right, up 0, click. Now we do the second point. So this time, the second point is 0, 3. Left, right, 3. Left, right, 0, up 3. Is that the point I want? Do y'all see where I'm looking? I moved down one. There. It's right up here where it's showing you the points as I move that mouse around. What do I have to do now? I can't check my answer yet. I have to save it to transfer the graph over here and then check my answer. Any questions?
No.
Looking at number 3, is this going to be a line? No, what's wrong?
X squared.
If we didn't have that x squared, it would be a line. If we didn't have an exponent there, it would be a line. But here we have a square, so the graph will not be a line. The second thing that we're going to be graphing, quadratics.
Can you move it down a little bit?
Yes, thank you.
Thank you.
Okay, quadratics must have an x squared term and no higher exponent than 2. That 2 there has to be the biggest exponent in the equation. I'll say, and no larger exponents. We're going to have a whole assignment devoted to quadratics in the near future, but for now we have a three-point graphing tool. The graph of a quadratic is a smooth U-shaped figure called a parabola. Graph is called a P-A-R-A-B-O-L-A. You expect the graph to either open upward or downward. As I said, we'll look at quadratics in much more detail in a later assignment, but for the time being, I'll just mention a little terminology. If a parabola is opening upward, there'll be a low point on the graph, a point where the graph has to change directions. If the parabola is opening downward, there'll be a high point on the graph where the graph changes directions. That point where the graph changes directions is called the vertex. And we'll have a nice way of determining the location of the vertex. But for now, once we get to that other assignment. But for now, we're going to be using a three-point graphing tool. To use the three-point graphing tool, they'll give us x values. We'll have to calculate y values and then plot the 3 points. So, what was it? X squared minus 4? Yes, this is number 3. The equation is y equals x squared minus 4. They say to create a table with at least 3 ordered pairs that are solutions to the equation and then graph the equation. I can tell looking at this, they're giving us an XY table and it's going to have exactly 3 ordered pairs. Let me write down that table. -2, 0, and +2. Okay, switching to my paper. This first row says plug in -2 for x and find y. So we're letting x equal -2. They want us to find y. So we have y equals -2 squared minus 4. We've replaced x with -2. -2 times -2, what is that? +4 minus 4. Oh, this is nice. It gives me a y value of 0. So there's my first order pair. -2, 0. What does the second row say here? Okay, so we're going to let x be 0. So we have y equals 0 squared minus 4. 0 squared is
0.
So we have 0 minus 4 is -4. So we got the second order pair. By the way, those of you sitting there near me, you don't have to worry. I am not contagious. We have, let's see, a 96 3/4-year-old woman, our mother, living with us. Our sister lives with us. Her son lives with us. No one else got sick. I am not contagious. This is just a run-of-the-mill sinus infection. I get them all the time, unfortunately. So if I thought I were contagious, trust me, I have a little mask right here. So I'd have that mask on. But y'all don't worry, I am not contagious. Third row on this table, what does it say to do?
X be 2.
Okay, so we're letting x be 2. So we have y equals 2 squared minus 4. That's 2 squared is 4. Minus 4 gives me a y value of 0. So we have the 3 ordered pairs. Any questions on how we completed those ordered pairs? My lab gave me the x values. We found the y values. Okay. Come over here. 0, -4, and 0. Check. And okay, now we're going to graph. Does one of those pictures look like a parabola? Can y'all see there's 6 tools here?
Yes.
One of them sort of looks like a parabola. Is this it here? When I'm looking at it up close, I see there are 3 little ordered pairs labeled there. And if we hover over it, use your bionic eye. What does that small print say when I'm hovering over it?
3-point quadratic.
3-point quadratic tool. That's what we're using. Click there. Then it says plot the first point of the curve. You can use the order of the ordered pairs doesn't matter. I'm just going to do it in the order in which we found them. What's the first one we found? -2, 0. Is that it? Do y'all see here in the upper, Tony, go point to the upper right hand corner where the ordered pairs are showing. It's underneath that X. Do y'all see that? As I move this around, and when the grid gets real tight.
I think they can see it, Tim. I don't have to go point.
Move your cursor there.
It's the
Y'all
upper
see it the way
right-hand
it's
corner of the
changing?
yellow rectangle.
Okay, so there, click, and then it says plot the second point. The second point we found was 0, -4. Is that it?
No, that's 0,
No,
-5.
okay. I was letting them answer.
Oh, I thought
Tony.
you just
Is
missed
that
that.
it? Is that it?
Yes.
Okay. Last point. Where is it?
There.
There? Then what do you have to do?
Save.
Save it. It'll transfer it back to the original grid. Check answers.
Hallelujah.
Any questions there?
No.
Number 7. Y equals x squared.
Quadratic.
That's going to be a quadratic. They don't give you ordered pairs to plot, though, okay? They don't give you the XY table. You're going to have to decide on the numbers you're going to plug in. My advice to you, definitely use 0, but use numbers close to 0. Don't decide, could I use
100.
Could I use
10.
Could I use 5? Can I plug in 5 for x? If I plugged in 5 for x, 5 squared is what? 25. So I'd go right 5. Can I go up 25 units? No. You got to make sure the numbers you're using fit on the grid they give you. That's one of the drawbacks to this these graphing tools, but it's not a bad drawback. Just make sure what you're plugging in. My advice to you, plug in something close to 0. So what do y'all think I'm going to use? You tell me, what do you think I'll use? Maybe -1, 0, and 1? Yeah, I think those would be good numbers to use. So this is number 7. Move down. Number 7. Y equals x squared. And we're making up our own table. So x, y, and we decided we'd use -1, 0, and +1. Plugging in -1 for x. -1 squared. -1 times -1 is? +1, I agree.
And right now might be a good time just to remind you of something that we said about these calculators. If you do this, it's going to give us what looks like the wrong answer. In order for the calculator, we know a negative times a negative. A negative squared has to be positive. But in order to get the calculator to give you the correct answer, when you're squaring a negative, you've got to put it in parentheses. Then it'll give it the correct answer. Okay? And that's how most calculators are working nowadays.
Plugging in 0 for x, what are we going to get?
0.
0. 0 times 0 is 0. Plugging in 1. 1 times 1 is 1.
I'll put those little ordered pair parentheses around there.
Oh, yeah. Tony likes to put the little ordered pair parentheses around.
I don't know why. Okay. So, click to enlarge.
You click that. This is a parabola. It's a quadratic. So we click the quadratic tool. And once again, we could label 1, 1 first. There's only one of the tools where the order of which you label those points on the grid matters. And we haven't gotten to that tool yet. But for this one, you could label 1, 1 first. Label 1, 1 first.
Okay.
1. Okay. Click it. Then 0, 0. And -1, 1. There.
Will it be right? Let's see. Oh, wow, you did it.
Okay. You know, maybe I should have used Roman numerals. I should have numbered the things for graphing. First of all, lines.
Then it's switch. Okay. So
Roman numeral 1 was lines. What was the second thing?
Quadratic.
Quadratic. Just see if y'all are paying attention. Quadratics. Now the third thing. Cubics. Quadratics have to have an x squared and nothing bigger. Looking at cubics, what do you think the largest exponent has to be?
Oh,
For a cubic. A cube, okay? It has to have an x cube. And there's no nice name for the graph of a cubic. Tony has a name for
My
one.
class once decided on a name for these.
For the graph of a cubic is can be
squiggly.
referred to as a squiggly. Okay, you'll see what I mean. So this is we're back to number 6 now. We want to graph y equals x cubed plus 5. And
Write down your table.
I'm going to write my table.
Well, here at least they give you the x's to plug in. That's
They
good.
tell us what to plug in. Good. I like for them to tell us what numbers to plug in.
-1, 0, 1, 2. So let's see what you put down.
Let's start with plugging in -1 for x. Here's my scratch work. I'm plugging in -1 for x. We'll have y equals -1 cubed plus 5. As I've said before, cubes and cube roots get a bad rap. People don't like them, but they're very nice. They don't change negatives to positives. A negative, when it's cubed, stays a negative. -1 times -1 times -1 is? -1 plus 5 gives me a y value of 4. So we've just got our first order pair. -1, 4. Plugging in 0, I think you can tell me the y value without us showing any work. 0, that'd be a 0 plus 5, I agree with 5.
0 times 0 times 0 plus 5.
Now, we're plugging in a 1 for x. Are we going to get the same thing we did when we plugged in -1? No, because 1 cubed is what? It's a positive 1. So you have a positive 1 plus 5. So the y value is 6. Tony, I was just telling everyone that I'm not contagious.
Oh, no.
You never got sick, but
But, really, 6 weeks ago, I might have been contagious, and that's why you got sick now.
oh wow, so there's a 4-week delay?
Yeah.
I wonder what sort of thing that is. Okay. Okay, and finally, plugging in 2. What color have I not used? I can use green. Okay.
Be careful. 2 cubed is not 6.
Two cubed is 2 times 2 times 2 is 8 plus 5 gives us 13. Any questions on how we filled in the table? They gave us the x values that we had to plug in. We calculated the y values. Let's come over here. Okay, 4, 5, 6, 13. Look at that. From the first 3 points, it looks like it's going to be a line. When we graph those first 3 points, I bet it's going to look like a line. Let's see. Oh, that's why this is one of those times where I recommend you be looking up here to see the ordered pairs, okay? Notice the 1, we're using a different scale. 1 is a big increment on the x-axis. But notice how small the increment from 0 to 1 is on the y-axis. So
You're
we
probably
gotta-
the only one that finds that interesting. You realize that.
you don't find it
Oh yeah.
interesting?
Well, I mean, the students are like, well, so what?
Oh, okay. Oh, goodness. You need to remember to wear that for St. Patrick's Day, Tony.
Oh, well,
If
I
we have
just
class-
realized I lost a pen. I mean, a button on here, so I'm going to have to chunk
Uh-oh.
it or find another button.
Uh-oh. Okay, so I forgot what we're. Y'all, let's see. Is this the tool I want? No. What about this one here? That says absolute value. That's what we're going to see next, okay? We know that's the quadratic. Look at this squiggly. If I hover over it, can y'all see what it says? 4-point cubic tool.
Do we have 4 points?
Yeah.
Do we have a cube in it?
This
X
big way?
cubed? Yeah,
Yes.
so that's it. So,
This thing right here is the circle tool, which we'll see when we're using graphing circles in a few class meetings. Maybe the next one. Now that I think of it. No.
we have lines.
Oh yeah, we have lines. Okay. I click the cubic,
Okay,
and then it
well,
says plot the first point. The
Okay.
first point was -1, 4. Was that -1, 4? It's hard to tell looking at that grid. Look there underneath that X. You'll see it says -1, 4. I click. Then 0, 5. Left, right, 0, up 5. Is that it? And then 1, 6. Hey, I said those first 3 points look like a line. And they sure do, don't they? I click it, but then the next one. 2, 13. No longer looks like a line. Click. I got my 4 points labeled. I save it to transfer it back. Check answer. Realize cubes generally get very steep very quickly. Let's just think about 5. Suppose you had tried to plug in 5.
Don't say 20.
5 cubed, 5 times 5 times 5 is 125 plus 5. So at 5 here, we'd have to be 125 units up.
No,
That'd be
130.
130. That'd be somewhere way out there. Okay, so realize you expect cubics to get very steep very quickly. Even say at 10, if you plugged in a 10, 10 times 10 times 10, that's 1,000. So when X is 10, you'd be way up there at 1,000, in this case 1,005. So any questions there?
At -10, you'd be down at -995. Okay. What's the next one? It was only
This
one
is
cubic,
Roman
right?
numeral, yes. There's Roman numeral 4 now.
Oh, the
Absolute value.
Remember one semester, getting in my office, logging on to my email. To my shock and horror, I had about 30 emails from the same class, students asking me about, number 5.
Number
5. Okay, I clicked on 4. I said, students asking me, telling me that messed up, that Pearson didn't, do it right. And I was like, it was all this problem here. Problem 5, absolute value. Did you write
And
it
you can
down?
spot,
Oh,
no, I'm
oh
not
you're going
gonna
to tell
do
them a
that
little
yet.
bit about absolute
You can
value,
spot
right?
the equation of an absolute value expression. Can you tell what has to appear in the equation? How do I know this is going to involve absolute values? Those 2 vertical bars, you see the absolute value bars, that's what says you're graphing an absolute value expression. Let's see.
What's happened, Tim? The people from those desks said that they were gone.
Now my students are just...
Oh, y'all moved away.
Oh, okay, good. Okay, so we don't bite, but some people like the peanut gallery. I suppose if I were a student, I'd be over there far away as possible from those weirdo
Those
teachers, those weirdo teachers. I'm going to sit far away. And for absolute value, the graph will be a V-shaped figure. A parabola I think of as a U shape. To me, when you make a U, it's a smooth U. Let's say you're going to write something like under. It's smooth, isn't it? It's a smooth curve. It's a V that has that sharp point. You expect the graph to be a V-shaped figure. It'll either open upward or it'll open downward. And we use that same terminology that we use with a parabola. There's got to be a low point or else a high point, and that's called the vertex.
But in all fairness, 99% of the time it's opening up.
Mm-hmm.
Yeah. Mm-hmm. Because once you take the absolute value of a number, what are you going to get? Whether it's positive or negative, once you take that absolute value, it turns positive.
Okay, so this is the only tool that matters how you're graphing it. You have to plot. You must plot the vertex first. Even though when you're making the table, that vertex may not be the first number that's on the table, but you must plot the vertex first. It's easy to determine the location of the vertex. The vertex for an absolute value expression will occur when the inside stuff is equal to 0. Switch back to that sounds weird, but if you look at this example, what x value, look at the stuff inside the absolute value. What would you have to plug in for x to make that inside stuff equal 0?
What? Nope, don't look at this. Don't look at the table
Equal
yet.
0?
To make that inside stuff equal 0, what would x have to be? 2. Okay, that's the vertex will occur when x is equal to 2. And that's going to be one of the points we have to find. But the vertex occurs when the inside stuff, for the lack of a better word,
Inside stuff
the
is about
inside
as good as
stuff
it's going to get.
is equal to 0.
And on this first one, they're going to give you the points,
The x
the
values,
x values to plug in. It'll make more sense once you see that. Then we'll do the next one where you have to figure out the vertex, and so you have to choose the points. So let's start. Okay, write down this problem.
We have y equals the absolute value of x minus 2. When I'm using absolute values, I try to make those bars in a different color so it doesn't look like y equals 1x minus 21.
We've already been through that.
So we're making a table of values. And the first number they want us to plug in is -5. So the first thing we have to do, the -5 is in the x column, so we're going to plug in -5 for x. That'll give me y equals the absolute value of -5 minus 2. -5 minus 2 is -7, so we have the absolute value of -7. What's the absolute value of -7?
Positive 7.
+7. So the first row of the table. +7. Where did I get that? That's a +7.
Okay, so
Come over, type in
7. And then it'll give you the next number.
The vertex.
Okay, you see 2. 2 minus 2 is 0. That step inside there is 0. So let's make a note. This is where the vertex is going to occur because they're going to make you plot that vertex first when you're using the graphing tool. So plug it in 2. Well, that's easy. What's the y value going to be? 0. The absolute value of 0 is 0.
And if I can interrupt, I'm circling with the cursor this statement, this sentence you wrote.
I'm
The
circling
vertex
both.
occurs when the inside stuff equals 0.
When does x minus, what number would you have to put in there for x to make that equal 0? 2. So 2 minus 2 is 0.
I think I got to type that in.
Yes.
0.
And finally, they want us to plug in 13. 13.
Oops.
We're plugging in 13. So we have x equals 13. So y equals the absolute value of 13 minus 2.
Wait,
What's,
was it positive 13 or negative 13?
I thought it was a positive 13.
Yeah, you're right. I don't know why.
13 minus 2 is 11. The absolute value of 11 is, no, the absolute value of positive, remember the absolute value is asking you, how far is that number from 0 on a number line? 11. How many units away is 11 from 0? You start counting the number of units. Are you going to get a negative number? Is negative 11 a counting number?
No.
So it has to be a positive 11. If the stuff inside the absolute values turn out to be negative, you drop the sign when you take the absolute value. If the stuff inside the absolute value is positive, then it stays positive when you take the absolute value. Any questions there? Oh, yeah, right in 11. So we type in 11. And now we're going to graph.
Should have known.
Click the tool.
Oh, yeah.
And they want you to choose the correct tool to draw the graph. We know that absolute values are going to be a pointed V. Notice if you hover over this V-shaped tool, it says absolute value tool, if you can read that tiny print. We click there. Now notice the instructions. It doesn't say just choose a point. You've got to plot the vertex. Even though negative 5, 7 was the first ordered pair you found, the first ordered pair you plot has to be the 2, 0.
That was the thing that every student in the class emailed me about.
Well, you must have forgotten to tell them.
Clearly I did.
You forgot
Not
to
only
say-
did I tell him, I recorded it.
So
Okay.
notice this is such a nice tool. I click the 2, 0. That's the vertex. Now it says plot another point. Notice as I move my mouse around, it's drawing in every
Every
absolute value of every
V-shape
V-shape that you could possibly get with the vertex at 2, 0. These V's are symmetric. If you drew an imaginary vertical line through that vertex and folded it over that vertical line, the right hand side is the mirror image of the left. So you only need one other point. They made us find 3 points for the table, but we only need one other point. What do you want to use? Negative 5, 7 or 13, 11? Either way, you'll get the same graph. How about 13, 11? Wait. Oops. Goodness, I'm moving it to
13.
no. Is that it?
Okay.
There's 13, 11. I click it. Now, if we go into negative 5, up 7, we're right there.
Oh, wait, I think you moved over to
Oh, way
negative
out.
4. Negative 5 would be right here, going straight up. Yeah, that would be that would be
You'd
7.
still get the same V
V
shape, okay? But this graphing tool is similar to the parabola graphing tool that we're going to have in a couple of assignments when we look at quadratics in much more detail. You'll find the vertex and plot it. You'll find one other point, and they'll use symmetry to draw in the rest of the vertex. Check. Any questions there?
Oh wait, why is it showing that?
Oh,
Go back to number 5. I think you went next question.
Oh, did I?
Okay.
Oh, there it is. Any questions?
Could y'all do one of these?
Suppose they didn't give you the table. You should know what's coming next. Number 8. They're not giving us a table. We're going to have to decide what numbers to plug in.
You've got to have the vertex, so why don't we find that one first?
That's what we're going to do.
Let's write it down.
Mhm. That's what I'm going to do, Tony. I'm going to write it down.
Wow, there's a lot of nice graphic stuff here. Mm-hmm. You can do this assignment. You know a lot about graphing. And they're going to learn even more. Okay. So
Switch to my paper.
the tool's still going to say,
Plot the vertex first. We have to find the vertex. So let's determine where the vertex occurs. The vertex occurs when the inside stuff, is equal to 0. When does x plus 3 equal 0? Not 3, be careful.
negative
3, good. So I'm making a table of values. I have to plug negative 3 in for x and make a note. That's where my vertex is going to occur. I'm not going to find 2 other points. I only need one other point. So,
what's the y value here?
oh, tell me the y value for the vertex. Negative 3 plus 3 is 0. The absolute value of 0 is 0. So there's the vertex. Now give me another number. We need to plug another number in for x.
Anything other than negative 3. Negative 2, negative 1, 0, 1, 2, 3.
I think 0 is a good one to plug in. That's pretty easy. Plugging in 0 for x. 0 plus 3 is?
3.
What's the absolute value of 3?
3.
Just 3. Any questions there? Do y'all want to see those calculations? X equals 0. So we have y equals the absolute value of 0 plus 3. 0 plus 3 is 3. The absolute value of 3 is just 3.
And since go ahead and go.
Oh, you want me to put the
See,
order?
when there's only 2 ordered pairs, I've seen students start going like this. Negative 3. Oh, well, heck, even if they did,
This time
it'd work out okay.
Okay, I see.
Mm-hmm. That's why I started doing that. Years ago, I had a student that would plot vertically like this, or this was the ordered pair.
You know, now
not
that you told me that, okay, I can see a purpose for putting those parentheses.
Okay, so click to enlarge. Which one is it?
The V shape that says absolute value tool. Now you got to plot the vertex. So the first order pair we plot is negative 3, 0.
Oh, wow, good. This is not 1,000,001 little lines.
Click it. Now it says plot another point. The point we found was 0, 3. If you had plugged in, say, a negative 1 or a positive 1, you'd still get the same graph. You might have different points showing, but you'd have the same graph.
Yeah, you'd have a over 1 up 4. It's still the same graph. Right? Over 2 up 5.
Let's save it. Check.
Mm-hmm.
Thank you.
3, 4.
Ready for problem 4 now? Let me see, which one?
Okay, the switch over.
Oh.
The fifth thing we're going to be graphing. Square root expressions.
Equations.
I'll just say
Say
square
square
root.
root. I wonder how we'll know when we have a square root.
How do you think we're going to spot that? Look at number 4.
Well,
If it's a square root equation, what do you see that indicates that it's going to be a
ignore
square
all of
root?
this over here.
The square
Square
root
root
symbol. It's easy to spot the ones that are square roots. Now, you're going to have to, there's not a graphing tool built into this course for square roots. So it'll be handled with multiple choice. We'll just graph it on paper and then choose the graph that looks the closest. Y equals the square root of x minus 5. This is number 4. Y equals the square root of x minus 5.
Mm-hmm.
You can't just start randomly choosing numbers to plug in for x here. This isn't like a line where you can choose any number you want to plug in for x or for y if they didn't give you the number themselves. Suppose I tried to plug in 0 for x. 0 minus 5 is negative 5. The square root of negative 5. What do we know about the square root of negative 5? It's imaginary. Imaginary numbers are called imaginary because they can't be labeled on a number line. So when you're graphing a square root expression, you have to make sure you don't get imaginary numbers. You have to avoid imaginary numbers. My process for graphing these things is sort of similar to what I do with absolute values. Absolute values, the first thing I ask myself is, when is the inside stuff equal to 0? That gives me the vertex. Well, for a square root, I ask myself, when is the step under there equal to 0? When is x minus 5 equal to 0? We can solve and get when x equals 5. Okay, 5 is now the starting point. That's where the graph is going to start. So I'm making myself an XY grid.
This graph has a definite starting point. All the other ones, they just went off, forever and ever, left and right, correct?
Right.
But here, there's a definite starting point. You can't put anything smaller than 5 in for x, like 4, 3, 2, 1.
If you put 4 in there, 4 minus 5 is negative 1. And we know the square root of negative 1 is imaginary.
Mm-hmm.
So we're going to have to plug in 5.
And what are we getting for y then?
If we plug in 5 for x, we get a 0. What's the square root of 0? 0. We can't plug in 4, so maybe we better go on the other side of 5. How about a 6?
If we plug a 6 in, are we going to get a real number or an imaginary number?
A real number. 6 minus 5 is 1. The square root of 1 is equal to 1. We could plug in a 7. It wouldn't give us a nice number, though. If we plug in 7, we're going to get what? 7 minus 5 is, so we have the square root of 2. That's about a 1.4. How about, since we're choosing the numbers ourselves, how about plugging in numbers that'll give us perfect squares? Like 8 minus 5, that's a 3. The square root of 3 isn't a perfect square. 9. Try 9. 9 minus 5 is 4. What's the square root of 4?
2.
So we now have the ordered pair. 5, 0, 6, 1, 7, square root of 2,
So 1.4.
and 9, 2. I don't think I even need this ordered pair. I'm just going to ignore it. We're going to graph this thing by hand, then we'll look back at the multiple choice options and choose the option that looks the closest to the picture we just drew. So I'm drawing my XY grid. Okay, so the first ordered pair we have is 5, 0. 1, 2, 3, 4, right 5, up 0. So there's my first point. That's my starting point.
If you look at where the cursor is, there's going to be no part of the graph going out this way, up or down.
If you have the
Nothing
graph
below.
over here, you're saying it's okay to plug in 4, and it isn't. 4 minus 5 doesn't give you a number you can label on the y-axis. Imaginary numbers can't be labeled on a number line. Now 6, 1, okay, right 6, up 1. I'm not going to bother with that 7, 1.4. The square root of 2 is about a 1.4. How about 9? That's 7. 8, there's 9. At 9, we're up 2 units. That number, that point you get where the inside step equals 0, that's your starting point. And it goes like this, and it continues to increase, but it does so very gradually. Think about this, at 105, if x is 105, 105 minus 5 is 100. What's the square root of 100? The way I'm incrementing this one, if I were counting out to 105, it'd be over there on that other table. But we'd only be up to about right out here, 10 units. So it increases, but it's a very gradual increase because of the way you're taking that square root.
There's no fancy names for square root equations, but they all look like this general shape. There's a starting point, and then it just goes up slowly. Notice it can't be going down because
if it were going down, that's saying the y values are negative. No, there's no sign in
the
front of that
symbol
y.
means positive square root, doesn't it?
That's right.
Okay.
Okay.
Now we'll look at all the. Which ones can I knock out? Is it? I'll start blowing them up. A.
Clearly not. B.
B.
No.
What about D?
That's another whole parabola.
I'm thinking it's. Is that it? Yeah.
It looks like they're incrementing in units of 2.
2, 4, so 5, 0, 6, 1, 9, 2, and it just goes up nice and slow.
So select. See? Any questions?
That's how I keep thinking every year they're going to change that.
And put in the graphing tool.
wait.
Who they have.
Okay. So.
And now we're ready for the distance and midpoint formula.
Okay, let me. So now, what we're going to be doing now is finding the distance between two ordered pairs and the midpoint, the point that lies right in the middle. So you're going to give them a couple of formulas.
The distance and midpoint formulas. Let's assume we have two ordered pairs. Just arbitrary ordered pairs. That could be anywhere on this grid. This is the first ordered pair. By first ordered pair, I mean it's the first ordered pair I've labeled, okay? To denote it, I'm going to label it X subscript 1, comma, Y subscript 1. That's saying the X in the first ordered pair, the Y in the first ordered pair.
First X, first Y.
And then I'm going to choose another, pick a spot, right? I'll put it right there. It can be anywhere on the grid. And since this is the second point I've chosen, I'll label that X subscript 2, Y subscript 2. The X in the second order pair, the Y in the second order pair. I'll show you geometrically what we mean. If you started at this point and drew a line segment to that other point, then you took a measuring tape. You positioned it starting here and measured the length of that line segment. That distance there, the length of that line segment, would be what we call the distance from the first point to the second point.
I bet they could have figured that out. I think they knew what
that length is equal to the distance.
Well, what's the formula? Oh, wait.
The midpoint. I think just from being alive, I have an idea. I always think of, when I'm driving to Houston, I always think of Victoria as the midpoint, which really isn't accurate, but still, just look. There's that line segment. Which point looks like it's right in the middle? Divides that segment in half. Maybe right out there. Does that look like it? That ordered pair, the one that divides the segment in half, we call the midpoint. So we're clear on what I mean by the midpoint and what I mean by the distance between 2 points. But how do you find them?
Write down
the distance formula D equals, has a square root. You subtract the x coordinates. I always go second x minus first x, quantity squared. But because of the way we're squaring it, you can put x1 minus x2. But I try to be consistent. I always use x2 minus x1 quantity squared plus y2 minus y1 quantity squared.
Second x minus first x squared. Second y minus first y squared. These little ones and twos here that I'm pointing at are not exponents. I've seen students put the little subscript up here like an exponent. No, the exponents go right there.
So the exponents are outside the parentheses. The midpoint formula, that's a little easier.
If I told you that you had two numbers and you had to average them, what would you do to average two numbers? How would you average two numbers?
Now you add them up and divide by 2. The x-coordinate of the midpoint is found by averaging the two x values you were given. Just add them up, divide by 2. You do the same thing for the y values. You add them up, divide by 2.
Generally, people think of the midpoint formula as easier formula because you're just averaging. Average the two x values, average the two y values.
Let's look at number 10, is it? Or 9? Number 9.
Hey, let's see. 9 and 10 are the exact same
I like to do the one with negatives.
I want to do the one with negatives. I want you to do the one with negatives. Yeah, number 9. They throw in this P and
P
Q.
negative 1714 and Q negative 12.7. Find the distance from P to Q, and the coordinates of the midpoint M of the line segment PQ. When they say find the distance, notice that notation. Below D means distance, and then inside the parentheses they're saying from P to Q. That's just their own made-up notation for distance. They could have just written out, find the distance from P to Q and the coordinates of the midpoint. So let me write down the ordered pairs. I probably don't. You're right. Let me move over here. Number 9. We have 2 ordered pairs.
Negative 17, comma 14, and negative 12, comma 17.
We'll identify, switch over. The first ordered pair I write down, I'm going to think of that as x1, y1. The first ordered pair I wrote down, I'll label that as x1, y1.
Ordered pairs are x, y. I've seen students in the past go x1, x2. No, 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 no.
We're not going to do that. The second ordered pair, for the since I wrote that down second, I'll label it x2, y2. And we're using our distance formula, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. I'll write down my square root. I'm leaving in the blanks there where we're going to be putting in the numbers.
Oops. Oops. This in red maybe should plug in.
Okay, x2, that's negative 12 minus x1 is negative 17. Watch those double negatives. y2 is 17 and y1 is 14. So now we've got to simplify this. Negative 12 minus a negative 17. What's negative 12 minus a negative? What's going to happen to these double negatives here? They become plus a positive. So what's negative 12 plus 17? 5. So we have 5 squared plus 17 minus 14. 3 squared. 5 times 5 is 25. Plus 3 squared is, so we have the square root of 34. Is 34 a perfect square? No. Is there a perfect square that divides evenly into 34? Think back to how we were reducing those square roots of, at the beginning of the semester. Is there a perfect square that divides evenly into 34? No.
4, 9, 16, 25. It's amazing. We did that first stuff we did, and we're doing it still.
So we're just stuck with the square root of 34 as our distance.
Now, it would be but 5 point something, right? If we did it.
Mm-hmm. So it's almost 6 units between those two. Not exactly 6.
We'll just use exact answers.
Mm-hmm. Notice they want an exact answer. They don't want a decimal approximation. Now the midpoint. Switch over. We know that for the midpoint, we have to average the x's, comma, average the y's, So here we're adding the x's. That's a negative 17 plus what's going to go here? Negative 12, I agree. Y1 here, 14 plus 17. Negative 17 plus negative 12 is negative 29 all over 2. What's the y coordinate going to be? 14 plus 17 is 31 over 2. There are no common factors. I guess you could convert to mixed numbers. There is a mixed number hot button key that I have never used in all of my years of using my math line. Algebra doesn't lend itself well to mixed numbers. I'd leave it as an improper fraction. And once I rule the world, I think I'm going to change that name to improper fraction. It sounds like it's a bad name because the numerator is bigger than the denominator. And in reality, there's nothing wrong with that.
So it's basically negative 14.5 comma 15.5, but
I think they want integers or fractions.
Integers or fractions. So what was it? Negative 29 over 2, right arrow. I don't want to put the comma down there. And 31 over 2.
Mm-hmm.
What's going to happen when I click check answer? Is it going to say right or wrong? Wrong. Your answer must be in the form of an ordered pair. Make sure you have enclosed your answer in parentheses. No biggie, except it doesn't do that on tests.
On tests, it would just count it wrong. Read how they want those answers typed. Even on the test, they'd have the instructions type in ordered pairs, so reminding you, type those parentheses.
However it's worded in homework is how it'll be done on the test.
So when it asks for coordinates, it's always going to be in parentheses?
Yes, but it says type an ordered pair. Ordered pairs have to be in parentheses. In general, midpoints must always have those parentheses around them.
Well, y'all want to do another one? There's a second one, number 10. The same instructions, just the numbers are different.
Starting with number 11, it's just a review of other stuff. Oh, remember these? Can't have a 0 in the bottom. Let's see, should we do one more, number 10? I'm going to play your part today and say, do it.
Papa's going to, Tony.
I'm usually the one that says, oh, we've done enough. No.
I was being radiated at the 1st of January and February of 2020, and they moved into the building, and so I wasn't here teaching class during those 2 months. And I remember I came right back, one class meeting before spring break of 2020, and that's when the pandemic started and the schools shut down. And I remember I was here having the best time in that one class. It was just great, okay? And then we were through, and I was like, Tony was like, okay, well, that's it, class. And I said, wait a minute, we still have 80 minutes. Let's do some more problems. And the students laughed and gathered the books together to leave, and then they realized
they didn't like you anymore.
They didn't like me anymore when it dawned on me. I was serious. They laughed and thought I was joking. And so I guess it's a good thing we never met with those classes again, because they didn't like me after that one class when I said, no, we don't have to leave early. There's other problems. Let's do some more problems. They thought I was joking.
First X, first Y, second X, second Y.
It does. Notice just the first order pair that I wrote down, that's what I label X1, Y1. The second order pair I write down, I label x2, y2. So
Write down
let
the
me ask you
formula.
something. Do you think the distance from P to Q, should that be the same as the distance from Q to P? If you put that measuring tape, if you start at P and measure to Q, would that be the same if you start at Q and measure to P? Is that distance the same? Yes. So it doesn't really matter which order pair you think of as x1, y1 and x2, y2. So our distance formula, just so I have something to point at, you'll notice I'm writing it down again. Okay, what number am I going to write here? 11, that's x2. Which number will I put here? Okay, that's right. Here, y2 is 20 minus, and there should never be a time you're subtracting one x into y. Realize the x's are paired together, the y's are paired together. Well, 11 minus 6, that's 5. So we have a 5 squared plus 20 minus 15, that's a 5. Well, what's 5 squared? 25 plus 25. Oh, that we can reduce this. The square root of 50. If you try to write the square root of 50, I don't know, will they just count it wrong or will they warn you that you haven't reduced it?
I wonder what they do. Will they just say wrong? What do y'all think?
On a test, they just count it wrong, I'll tell you that much. So they're saying that your answer is equal to the correct answer. It's not in the correct form.
Yeah, make
What's
sure
the
your answer's
largest
fully
perfect
simplified.
square that divides evenly into 50?
I'll give you a hint. Yeah.
25, so you're thinking of it as the square root of 25 times the square root of 2, and the square root of 25 is, so 5 square root to 2 is the distance.
So it'd be close to 7. It's 7.1 or so.
Okay, now the midpoint.
Like-
Oh, go ahead and type in the answer.
I forgot what.
2 is underneath it.
5 square root
root
of
of
2.
2.
5 square root of 2. Check it. Now the midpoint.
Okay, the midpoint.
What's that formula for the midpoint? Well, average the x's, average the y's. By average, I mean add them up, divide by 2. This is pretty easy. There's not even a negative on this one. I like the way you're writing those ordered pairs, Tim. That's what I've got to write down or plug in.
Okay, x1 is 6. Y'all tell me what I'm going to write here. 11. Here, I agree. And 20. Oh, let's see, 6 plus 11, that's 17. So we have 17 halves.
If it said enter a decimal, you'd write 8.5, but they don't say enter a decimal.
15 plus 20 is 35.
If it said enter a decimal, you'd say 17.5. But it
Notice there's
doesn't.
no common factors in the numerator and denominator, so you need to leave your answer like that. Left parentheses.
17 over 2. I'm not going to put the comma down in the bottom of the fraction.
You just did.
I know, about to erase it, okay?
Right arrow,
Comma,
35 over 2.
I'm not going to put the parentheses down there. It'll count it wrong.
I hope it does. It's counting all of it.
Yeah. Any questions
Any
over there?
questions?
So we saw a lot of nice little graphing tools, and then you had two formulas. Distance formula and midpoint formula.
Any questions? What are we doing on Wednesday?